Is Docker overhyped and it's finally time to switch to Podman in 2025? If you're working in DevOps or cloud computing, you must have heard these names, Docker and Podman. But what exactly are these tools? Why they are always compared? And do you really need to choose one over the other? Let's get started. Both Docker and Podman are the tools used to containerize application. To understand what that really means, let's try to understand this with a simple example. If a company builds an app and wants someone to test it, you don't want them wasting time setting up tools, installing libraries, or matching machine settings. So instead, you bundle everything up, the app, its dependencies, and its environment into a container. Then you send that container to the tester. They just run it and everything works right away. No setup required. Now, the tool that really made working with containers simple and widespread is Docker. Docker let you write a set of instructions into a file called Docker file. For example, you can tell it to use a base operating system, install Python, copy your app files, and then run it. Based on this, Docker builds an image, a kind of a blueprint of your app. And from this image, Docker creates a container that runs your app exactly as intended. Now, let's try to understand how Docker does this. Docker uses something called Docker daemon. This is a background process that listens for your command and handles the actual building and running of a container. So every time you run a Docker command, you are really just sending instructions to this daemon, which then executes your request. But on most Linux systems, the Docker daemon run as a root user. That means it has a complete access to the system. And if a developer creates a container but don't follow the best practices, maybe they leave the port open unnecessarily or the app inside the container downloads the package from an untrusted source. Eventually, the hacker finds a way in and the container gets compromised. And since the Docker daemon has a root access and the containers talk to the daemon, now the hacker has a path to escalate the control. They can potentially create new containers with full system privileges or even interfere with a host machine. This is called security escalation, and it's a serious risk, especially when the production system where the stability and security is everything. There is also another problem. The Docker daemon becomes the single point of failure. This means your system runs out of memory or Docker services crashes, the daemon goes down, and all running containers can go down with it, which means everything stops at once, which is far from ideal in critical systems. To address these limitations, Podman was introduced. Podman is also a container engine you can use to build, run, and manage containers just like Docker. But the way it works is quietly different. Podman doesn't rely on a daemon at all. It executes all command directly, which means there's no background services constantly running and no central process that everything depends on. This daemonless architecture reduces the risk of failure and improves reliability. It also supports rootless containers. So if a container is compromised, it doesn't have access to entire system. It runs at the user level. Now, hearing all this, you might be thinking you should we switch to Docker altogether. Not so fast. Docker has been evolving too. One of the major issue running container as root has already been addressed. Docker now support rootless mode, allowing containers to run with limited permissions, reducing the risk of security escalation. And for the daemon issue, with the proper monitoring and sufficient resources, it can be managed effectively. But unlike Docker, which added rootless mode later, Podman was built with a security in mind from the start, offering a daemonless, rootless design by default. And just because it's rootless doesn't mean it's limited. You can still map ports, mount volumes, and run complex multi-containers app just like you would with roots. Now, you might be thinking again, do I need to learn a whole new tool just to use Podman? Fortunately, no. Podman was intentionally made to be compatible with Docker CLI. Most of the commands you already use like Docker build, Docker run, or Docker PS works the same way with Podman. You can even create a shortcut by running this command and everything just continues to work with no major changes needed. And there is also a tool called Podman Compose, which aims to replicate the functionality of Docker Compose, a tool commonly used for defining and running all the multi-containers application. While Podman Compose isn't as feature-rich as Docker Compose yet, it is improving and work well for simpler setups. And if you prefer graphical interfaces, Podman also offers a GUI called Podman Desktop, which works quite similar to the Docker desktop. On top of that, Podman has one more neat feature, support for pods. Similar to how Kubernetes works, You can group containers together, share network between them, and simulate the mini Kubernetes cluster locally. And this is a big win for a developer working on cloud native app who wants to test things before deploying them into real world Kubernetes environment. Podman can actually export pod definitions as Kubernetes YAML files so you can test locally and deploy it to the real clusters with minimal changes. But how do you actually create a pod? First, make sure that you have got Podman installed on your system. There are official installer you can get from Podman official website. After installing Podman, you can just open your PowerShell and type your first command podman pod create. This command will create a new empty pod, and if successfully created, it will return a pod ID like this that you can see over here. And the next command can be, if you want to list all the pod, you can just type podman pod list. This will basically return you pod ID, name, status, created, and infra ID. These are the auto-generated names that would be required while adding a container to the pod. And if you want to list all the containers in the pod, you can just type podman ps/a/pod. This will basically show you all the containers grouped by the pod and each container ID, image used, and the command running. And if you want to add a container to the pod, you can just type podman run. Just coolmores is the name of the auto-generated pod that we just created. This will basically add a new container to the existing pod, and the name of the pod is coolmores, and this uses Ubuntu image and runs the top command. And if you want to view the pod with updated container, you can just type podman pod ps. This will basically show you pod ID, name, status, and the created infra ID, and it will show you that the coolmores is running and the container has been deployed to it. And if you want to restart the pod, you can just type podman start, and you can just put the pod ID. If you want to restart the pod, you can just put the pod ID over here. You can just use your pod ID in this part. This command will basically help you to start the pod again along with all its containers. So, do we absolutely need to use only Podman? Not necessarily. If Docker is working well in your current environment and you are not running into any issue, there is no urgent reason to switch. Also, Docker is more beginner friendly because of its massive online community, rich documentation, and pre-built images on Docker Hub. This makes onboarding smoother for new developers or teams starting out with containers. And there's more. Docker is still one of the most popular and well supported container tools. It has strong community, plenty of third-party support, and keep adding useful features. Recent updates include Docker Build Cloud to speed up the image build, test containers for easier testing, and Docker Init to auto-generate Docker files. If your team uses Docker Swarm and relies on CI/CD tools, Docker-wide support makes it good choice. But if you work in an industry where security is important, like banking, healthcare, or government, Podman might be the better choice. It's a vendor neutral, OCI compliant, and doesn't stick you into one ecosystem. Along with this, you can push your images to Docker Hub or other registries. You can get clean, rootless architecture from start. However, from personal experience, I have seen few challenges. For instance, running Podman on Mac OS can be a bit tricky. Sometimes container doesn't start as expected or network configuration get complicated. And when you try to use Podman with Kubernetes, especially for custom networking, the setup isn't straightforward as Docker, at least not yet. In the end, it's helpful to think of Docker and Podman not as a rival but as a different tools built for slightly different goals. Docker is polished, versatile, and tested, and on the other hand, Podman is minimal, secure, and precise. Now, to wrap this up, Docker revolutionized the container world by making containers easy and accessible. Podman stepped to improve the security and flexibility. Both tools are powerful, and choosing between them really depends on your project, your team priorities, and the kind of environment you're working in. Thank you so much for watching this video. I hope this cleared up your confusion between Docker versus Podman. If you found it helpful, don't forget to like, share, and subscribe. And I will see you in the next video.